Hi, I'm Dr. Julie Whitney, and in this final video, I'm going to show you some signal processing techniques you can do in MATLAB, and plus generally talk about signal processing and how it's used. Signal processing is the science of manipulating signals. All signals, light, sound, digital images, electrical waves, can be manipulated. It's an enabling technology that's gotten more and more attention in the digital age. The goal is to encode, transmit, and then unencode information, or just to extract information, as you'll see in the last example in this video.
Here's something fun to do. There's a MATLAB program I wrote that long ago, and it uses the microphone in your computer to do some recording. So let's try it. I'm going to take this line right here, and I'm going to copy it onto my command line. And what this does is it creates an object, kind of like the Arduino or servo motor, for the audio recorder inside my MATLAB. So next thing I'm going to do is I'm going to record my voice for 5 seconds. So as soon as I hit go on this one, it will start recording for 5 seconds. So here we go. 1, 2, 3, 4, 5, 6. Now I'm going to try to get that data right here. And I'll plot it. Okay, I'll move that in so you can see it. There we have the sound that I did. 1, 2, 3, 4, 5, 6. And then I started talking to you again. So here is a signal. Okay, there is a little bit of noise in the background, and you can see that the human voice is it's a rather messy signal. It's full of little digital samples. There's that one right there, an X and a Y. Okay, where X is your time and Y is the amplitude of the wave. So let's put that aside just a minute, and let's go ahead and listen to what it just recorded. One, two, three, 4, 5, 6. Now I'm going to try to get. Okay, so that's fun. We have our sound now. We have our signal. Now, signal processing doesn't have to be getting rid of noise. Signal processing can be doing some fun things too. I'm going to play that same sound back now at twice the speed. So I'm going to go twice as fast here. I'm basically skipping every other data point to speed it up. So you have fun with that one. You can also do a Fourier transform on this. We're talking about Fourier transforms. A Fourier transform is, instead of time being on that horizontal axis, you're looking at frequency. So sometimes my voice is high, and sometimes it's low. And sometimes there's background, which is not there at all. And so this puts the whole sample it did in terms of how many pieces it saw at what frequency. And you can see that the human voice has a very definite pattern of frequencies that it's in, but it's not just one frequency. So let me go get that plot. There it is right there. You can see that there's a main frequency. You can see there's a nice bell curve of the frequencies that the human voice is in, and a range that we don't normally get to. So that down here, this is probably the background noise in the room. Okay? So that's a little fun thing that you can do in MATLAB and play with signals and process them. You're not necessarily getting rid of noise. Now, if I wanted to get rid of noise in that one, I could have just done a filter on it. So there we go. Here's another fun one for image processing. Again, we're not trying to get rid of noise, but we're trying to bring out something about the image. I'm going to start with a picture of a kitten, and I'll show you what that looks like. I've pulled in and off the web, and of course there's lots of pictures of kittens on the web. Here's my kitten. And I'm going to turn him first into a grayscale image. I'll move him out of the way, and I'm going to make him a grayscale image, just so that there's less I have to deal with, because of course a 3-color thing is hard to deal with. So, turning him into a nice gray kitten. So there's my gray kitten. Okay? So, what we're going to do is we're going to apply a Fourier transform and pull out just the low frequencies. And in doing so, we're going to blur the picture of the kitten. So you remember what that kitten looks like now. And we're going to get rid of that. So it comes out nicely. I am going to blur the kitten. So I'm going to pull this up here. Use a Gaussian filter. C, Control V, and we should be able to show. There's the blurred kitten, and you can see indeed the kitten is quite blurred. Let's see if I can move that over now. There we go. Move blurred kitten over. Now I'm going to subtract that blurred kitten from the original kitten. Sorry. And that's now hidden behind here. There it is. So what happens when I subtract is I get just the lines. So the blurred image subtracted from the original image gives you just those very sharp lines. And so this is a way to pull lines or edges out of an image.
This setup is to demonstrate what happens with signals. I have a speaker hooked up to an oscilloscope, hooked up to a function generator. And when we increase, we have it set at 1 kilohertz, when we increase the amplitude, you can see the signal showing up on the oscilloscope, and that's what's creating the sound on the speaker. And when we change the frequency, the pitch changes. In addition to these fun kinds of things, signal processing can be applied to very practical problems. These images show an example of that. They're images of cancer cells being treated with an experimental heat treatment using carbon nanoparticles caught inside the cancer cells to concentrate the heat. The goal of this image processing is to count the number of live and dead cells, to see how effective the treatment was. So the steps of this image processing are as follows. And by the way, these will sound a lot like the image processing steps you're doing on your project. Number 1, they used a threshold to remove the carbon nanoparticles. They're black, so they can be taken out. Then, number 2, they ratioed the red to blue pixels to identify which pixels were the nucleus of the cell and which were not. And finally, they used frequency filters to find edges. High frequency is a quick change in the intensity of the pixel, and in an image, a quick change is likely to be an edge. The 4th step was to combine all these together. So there you have it, 3 videos on signal processing, the signal, the noise, and the world of things that you can do with this technology.